Okay, so we looked at how to solve problems when you have fluctuating loading. So what if you have combined stresses? Let's say, meaning you have a fluctuating bending load and you also have a fluctuating torsional load, or you have fluctuating bending load in two different directions, right? So that is going to complicate. Okay, so that is going to make it even more complex. So in this case, what we use is the distortion energy theory. So distortion energy theory, you have, according to distortion energy theory, this is the most general equation: sigma square equals 1/2 sigma x minus sigma y whole square plus sigma y minus sigma z whole square plus sigma z minus sigma x whole square plus 6 tau xy square plus tau yz square plus tau zx square. So we will be using this theory, this equation, to combine the different stresses acting, different variable stresses acting on the member. So let us first copy this. Okay, fine, all right. So let's say we have two-dimensional stresses. Let's say you have a member with sigma x and sigma y. Sigma x is fluctuating stress, so it has a mean component and a variable component. Sigma y is also fluctuating stress. So in this case, your sigma z is 0, tau xy no shear stresses, tau yz, tau zx is all 0. So if you substitute these values in your earlier equation, in this equation, we get sigma is equals square root of sigma x square minus sigma x sigma y plus sigma y square. Okay, so you use this relationship. So you have sigma x has sigma x mean and sigma x a, which is the alternating component or variable. Sigma y also has sigma y mean and sigma y a, amplitude of the variable stress. So now you calculate sigma m as square root of sigma xm square minus sigma xm sigma ym plus sigma ym square. Same thing with sigma a. Sigma x a square minus sigma x a sigma y a plus sigma y a square. Once you once you have these, you use your modified Goodman diagram to solve the problem. Okay. What if we have combined bending and torsional stresses? So we have sigma x bending stress which is fluctuating, and you have tau xy shear stress, torsional shear stress. This is also fluctuating. So you do not have sigma y, sigma z, tau yz, tau zx, xz equals 0. So if you use all of this in your very first equation, in the distortion energy equation, what you get is sigma equals sigma x square plus 3 tau xy square. This is a equation that you get. Now so the mean stress now will be sigma xm mean bending stress plus 3 tau xy mean torsional shear stress. Sigma a is sigma amplitude of the bending stress, amplitude of the torsional shear stress. So use these two, sigma m and sigma a, in modified Goodman diagram. So you have your SE SYT SUT. This is your modified Goodman diagram. So you have your sigma A and your sigma M. So you have your load line. So you have your limiting value of stresses SA and S. or you use your equation SA by SE plus SM by SUT equals 1. If we are using this part of the line, then this is the equation. Okay.